All right, so this is the beginning of our spring note pack. And remember that you need to have this note pack with you every single day when you come to class, and you need to have your notes completed every single day. Notes will not be long. They are very necessary, and I'm pretty unforgiving about that, so you need to have them done. All right, so we're going to start with section 5.1, expanding and condensing exponents. Some of this may be reviewed to you. Really important concept, though, that we make sure we practice and do correctly. So the first thing we want to go over is what exactly is an exponent. So when we have an exponent, we have the number that is the base, which means the number that's being multiplied by itself, and we have the exponent, or the power. Okay? And what that really means is 3 multiplied by itself five times. Okay, so we're going to go down and do some examples of those. So let's say I have 7 to the third. Well, my base is 7, my power is 3, which means that is 7 times itself 3 times. So remember, it's not 7 plus 7 plus 7. That answer is not 21. When things grow exponentially, they grow really, really, really fast. So if I was going to multiply that, 7 times 7 is 49. And then I would have to multiply that by another 7, which actually gives me 343. It's a really large number that grew really, really, really fast. Okay, even if we have a fraction can be a base. A base is just the number that's being multiplied. So let's say that we had 1/4 is our base. And let's say we wrote it like this, 1/4, and the base is 4. Okay, so that means that my base is 1/4 and my power or my exponent is 4. And what that means is 1/4 times itself 4 times. So remember, when you multiply fractions, you just multiply all the tops together, all the numerators together, and all the denominators together. So in this case, we would have 1 times 1 times 1 times 1 is 1, and 4 times 4 is 16. We have another 16 over here. And 16 times 16 is 256. So just as whole numbers get larger a lot quicker in exponential functions, if they're a fraction, they get really small really fast in exponential functions. Okay, so now we're just going to write these next 6 just using exponents instead of expanded form. This is called expanded form. We're going to put them down into exponential form. So I just need you to tell me the base and what the power is, how many times it's being multiplied. So here my base is 4, and I have 1, 2, 3, 4, 5, 6 of them. -3 is my base. You need to make sure you put parentheses around that, and I have 3 of them. My base is 2/5, and I have 1, 2, 3, 4, 5 of them. Okay, I'm not asking you to multiply them out at this point. We'll get to that. My base is x. Bases can also be variables. We're going to deal with those a lot. We already kind of have. And I have 4 of those. Now here you've got 2 different bases going on, okay? And there's a different amount of them. So the way I want you to write that is one at a time. Deal with your coefficients and deal with each individual variable, okay? So I've got 2 5s, and I've got 1, 2, 3, 4, 5 y's. Now I am going to expect you to multiply this out at some point. We can do that pretty easily. 5 squared is just 25. So my completely simplified correct answer would be 25y to the 5th. You can do the same thing on letter F. So I have 3 as my base, and I have 3 of them. I have another base of x, and I've got 2 of those. And I've got another base of y, and I've got 4 of those. So simplifying that, remember, really common mistake is to say, okay, well 3 times 3 is 9. But remember what that's saying, 3 times 3 times 3, which is 27. And then we can rewrite the x squared and the y to the 4th. All right, now we're going to flip that around. Now we're going to expand our exponents. Okay, so we have 3 4s, so you should have 4 times 4 times 4. 2/3 to the 5th would be 2/3 times itself 5 times. Negative 3 to the fifth would be negative 3 times itself 5 times. You can see when you're multiplying how that number would get exceptionally large or small really quickly. Okay, m to the fifth means simply m times itself 5 times. I actually find variables with exponents to be pretty easy. I think you will too. We've already kind of dealt with that in my class with square roots, and you'll see that again for sure. So 3 squared would be 3 times 3, and then x times itself 5 times. When you write variables like this, you don't necessarily need to put the dots in between each. It's kind of assumed that those are multiplying together. When you have coefficients, you definitely need to put the dot, because if I left the dot out of that, it would look like 33 and not 3 times 3. So that's just something to be aware of. And then we have 5 times itself 4 times. I have a couple of x's, and then I have 3 y's. Okay, great. Let's go on to the next page. So now we're going to get into some of the rules with exponents that will make our simplifying a lot easier. So our product rule says that when we have the same base with different exponents, as long as the base is the same and being multiplied together, you can just add the exponents together. Okay? So for example, if you had a base of x to the third times x to the fourth, well, think about what that really means. That really means x to the third and x to the fourth, and we're really multiplying those all together, which means we're adding the exponents together, which means we would have x to the seventh. So same thing here. As long as your base is the same and you're multiplying them together, that really means 2 times 2 times 2 times 2 times 2, 5 times, right? So you just have to add those exponents together. So you've got 1, 2, 3, 4, 5, 6, 7. 2 plus 5 is 7. So 2 to the 7th. Okay? Remember that if you have no exponent on a base, it's always assumed to be 1. So this 3/4 is assumed to be 1. So that really means 3 to the 4th, and then 3 to the 4th squared, of course, is 3 to the 4th times 3 to the 4th. So I have 3 of those all together. 1 plus 2 is 3. So this equals 3 to the 4th to the 3rd. I'm not going to expect you to write them out every time just like this, but when you're learning, sometimes it helps to see it in expanded form to help this make more sense. Okay? So I've got the same base. My base is negative 4. I have a 2 and a 3. I'm going to add those together, and I get negative 4 to the 5th. Same base here. I'm going to add those together. 3 plus 4 is 7. Okay, now here, this is really going to help to see it in expanded form and see what this really means. So this is 2 and x to the 3rd. 4, I'm actually going to change into 2 times 2 and give it what we call change of base or same base. This is going to help a lot, and change of base is something that we're going to work on in the exponent unit to make all of it much easier for you. So now you can see that I've actually got 1, 2, 3 2's, and of course I can add my x's together. 1, 2, 3, 4, 5, 6, 7. Remember that unless there's a parentheses involved, that exponent only applies to whatever is directly in front of it. So this third power does not apply to the 2. It only applies to the x. So that will give us x to the 7th. If you're going to simplify that down more, 2 to the 3rd is 2 times 2 times 2, which is 8. So we could simplify that even more. When you're getting really good at these, you're going to multiply your coefficients together first. So 2 times 4 is 8, and then just add your exponents on the variables, and you'll get the same answer here. So here we've got 2 different bases going on. We have 3 to the 4th and 3 to the 1st. If there's no exponent, we assume that it is a 1. So if I add those together, I've got 3 to the 5th. And then on my base of D, I have 2 and 4, which gives me an answer of 6. Yes, you can multiply this out. I'm not concerned about that too much at this point. I'll let you know when to be concerned about that. Okay, power rule means when you are raising a power to another power. Again, expanded form kind of helps here. And what you're going to do with those is you're going to multiply the exponents. I'll show you how that works. Okay, so 2 to the third squared really means 2 to the third times 2 to the third. Well, now you know from the product rule that if I have the same base, I can just add those exponents. So 3 plus 3 is 6. And the rule tells me that I can multiply my exponents together. 3 times 2 is also 6. Okay. Expanded form just kind of helps see what we're dealing with. So 5 to the third, all raised to the fourth power, would be 5 to the third times 5 to the third times 5 to the third times 5 to the third. Using this rule, I know I can add those together. 3 plus 3 plus 3 plus 3 is 12. Well, it makes it a lot easier to know I can just multiply those exponents together and get 5 to the 12th, because then I can skip this expansion step altogether. Okay, so when you raise a power to a power, you're going to multiply those exponents. So 4 times 2 is 8. Now, here's something that I want you to be sure, remember that when you're raising to this outside power, everything inside the parentheses is being raised to that power. So again, if we write it out in expanded form, we would have 2x to the third times 2x to the third times 2x to the third. Well, what I really end up having is 3 2's and 9 x's. So what I did was, that 2 is the same as 2 to the first. It's kind of a distributive property idea. 1 times 3 is 3, and 3 times 3 is 9. You can further simplify that to 2 to the third is 8, x to the 9th. Either one of those answers would be okay. So remember that everything in the parentheses needs to be raised to that power. So you can kind of do a distributive property. 3 times 3 is 9, and 2 times 3 is 6. Okay. Quotient rule, so now we're talking about division. So I want you to think about something. With our product rule, when we were multiplying, we added the exponents together. So now that we are dividing, I want you to think about what would logically make sense for us to do with our exponents. And that is that we are going to subtract the exponents. Now, I'll give you a couple of ways to do this because I think this becomes a little bit problematic when you get into negative numbers. But for now, you have the same base, and this is going to equal 2 to the 4 minus 2. It's the exponent of your numerator subtracting the exponent of your denominator. So 4 minus 2 is just 2. So we'd simplify that as 2. And really, if you wrote it out, again, not something you're required to do, but sometimes it really helps. Okay, and then you can cancel. So you cancel 2 of those, and you would have 2 left on the top, and you get 2 squared. One of the ways I tend to explain it is, do you have more on the top or the bottom? I have more on the top, and by how many? Well, 5 is 2 more than 3, so that's x squared. And you only have a 1 on the bottom. Okay, coefficients here. What this really is 10. Let's think about what this really means. This is 10, and then 7 x's, 1, 2, 3, 4, 6, 7, and 2 x's, right? Well, 2 can go into 10 5 times, and 2 of those x's are going to cancel out, leaving only 5 left. So we really get 5x to the 5th. So coefficients are treated kind of as their own fraction. You just simplify that. And then you can ask yourself, do you have more x's on the top or the bottom, and by how much? Okay. Same thing again. 3 over 12 reduces to 1 over 4. And I have more y's on the top than on the bottom, and I have more by 2. This can also be written, you can leave that 1 off and just write it as y squared over 4. So if you see something that looks like this, you're rarely going to see that 1 with it, so just recognize that those mean the same thing. Okay, and last one, and you can actually treat these as their own individual fractions as well if you're still a little bit confused. And don't worry, you're going to get plenty of practice to unconfuse you. But you can actually treat them as 3 separate fractions. So my base is 2. Do I have more on the top or the bottom? I have more on the top by 3. My base is x. Do I have more on the top or the bottom? I have more on the top by 1. And my base is y. Do I have more on the top or the bottom? Well, this one, remember, this is not a 0. This is y to the first, and I have more on the top by 4. So you can write that as 2/3 xy to the 4th, or you can multiply out the 2/3, which would be 8xy to the 4th. You can always leave the 1 in there if you need to. Any of these three answers would be acceptable. Okay, great job. That was section 5.1. Thanks.